All right, so section 7.6 is going to have us solve rational equations. Let's take a quick look at what rational equations are to get an appreciation for what kind of things we're going to do. Rational equations are equations that have ratios, and more importantly, you're going to have variables that are in the denominators of these ratios and proportions and other equations. So the idea in working with these things really recognizes the fact that most of you don't really like fractions, so our goal is going to be to get rid of the fractions right away and then just work with solving the resulting equation from there. How are we going to get rid of the fraction? Pretty simple. We're going to multiply everything through by the lowest common denominator. We'll start with problem number 24. I'm going to write it slightly different than the book does. I'll write it as 3 over 4b plus 2 over b equals 1. So, hang on. Aaron, just maybe after 11 o'clock, I'll be done with class and try it then. But right now, my sound doesn't work too well. Doesn't play off the projector loud enough. Thanks. So, what's the lowest common denominator here? Both of them, yeah. 4 and b. So the LCD here is 4b. So to get rid of all the fractions in this one, what I'll do is I'm going to multiply everything by that LCD on both sides. How's that going to look? Well, on the right-hand side, I'm going to multiply by 4b. On the left-hand side, I'm going to multiply by 4b. But on the left-hand side, I can distribute that 4b, right? It's not just 4b times this, it's 4b times both of these. So the shortcut in this is that everything gets multiplied by the LCD. Yes, ma'am? Well, you'd have to include the 4 as well to be part of the LCD, because this doesn't have the 4, but this does. But if you had two fractions, say 7 over 4 and 2 over 1, is the LCD going to be 1 or is it going to be 4? It's going to be 4, right? Okay, and in a similar way, 4 is part of our LCD here. Now when I multiply everything through by my LCD, at least on the left-hand side, I'm going to get some cancellation. So the b's will cancel, the 4's will cancel, and that's nice because that just leaves me with the 3. How about for the middle term over here? Is there any cancellation here? The b's disappear. And so what am I left with? 8, 4 times 2 equals 4b. Let me take out my calculator for a second. 3 plus 8, oh, there we go, 11. All right. Now, last thing to do to solve is just to divide both sides by 4, right? So 11 over 4 equals b. Yay. And we should check our answer here. And when I say should, it's more of a polite way of saying you have to check your answer. And that's because we're solving rational equations. And these are going to be a little bit different in nature than the typical quadratic equation that we've been working with. Back when we were solving quadratic equations, it was a good idea to check your answers. Here, you've got to check your answers. So let's do that. And later on, if you're interested, maybe I'll show you a way to check it with a graphing calculator. It's not too bad here. But what do you think I'm going to do to check my answer? To know that this actually works? Yeah, plug 11 over 4 in for b. And let's see that that works. Okay, so it's going to be 3 over 4 times 11 over 4 plus 2 over 11 over 4. And somehow or another that's supposed to equal 1. Let's see that that does. Well, over here, the denominator, the 4 and the 4 can cancel, right? So I'm left with 3 over what? 3 over 11. Good. Now in this one, when you divide by a fraction, the rule is to do what? Dividing by a fraction is the same thing as, thank you, multiplying by the reciprocal. So when I multiply by the reciprocal, 2 times 4 is 8. 3 over 11 plus 8 over 11 is 11 over 11. Let me see here. Wait. So 11 divided by 11. Oh, I'm kidding. That's 1. It works. The left-hand side equals the right-hand side. So, yay. In this section, though, you have to check your answer because sometimes when you try plugging this number back into the original equation, something goes really, really wrong. That would happen, for instance, in this equation if you had b equals 0. What would be wrong with having b equals 0 as a solution? Well, when you try check it, what happens? You'd be dividing by 0, right? You'd have 2 over 0. You can't divide by 0. It's undefined. So you have to throw that solution out. And what you have to worry about in this section is that your solution, when it's all said and done, could put a 0 in one or more of the denominators you have. If that's the case, you'll cross it out and just write it's an extraneous solution. So we'll keep an eye out for that. Let's move on to problem number 30. Five over 14 minus 1 over 2x equals 3 over 7. So kind of like the last one, no one likes fractions, and so we're going to try and get rid of the fractions by multiplying through by the lowest common denominator. What's the LCD in this case? 14x. Good, thank you. So 14x is our LCD. So everything gets multiplied by that LCD. So 14x, 14x, and 14x. If it's helpful, you can write that 14x over 1. But the idea here is that you want to do the cancellation. Don't multiply 14 by 5 and get 90. Cancel the 14s to get rid of that denominator here. So you're left with a 5 and an x. What else can we do? Well, we get some more simplification here, right? What cancels what's left with 2x and the 14x? Madison? All right, 2 cancels in there 7 times, and the x's disappear altogether, right? So yeah, so just a 7 here. And the last one. Elizabeth? 7 goes into 14 twice. What's left? 3 times 2 times x will be a 6x. All right, not bad. Almost done. Ying, what do we have to do to finish solving here? Since 6 is bigger than 5, I think I'd subtract 5 from both sides. But you could do it subtracting 6x. That would still work. Should be a 5. And there you go. There's your solution. One step and done. Does this create a problem with our denominators? If I put in a -7, is that going to give me a 0 in the denominator? No. So we're okay. If you wanted to, you could actually check it out by hand like we did with the previous problem and show that it actually does work as a solution. I want to give you a couple more to try. Problem number 36. D equals 4 plus 21 over D. What's the LCD for this one? D, right? Now, even though this doesn't have a denominator, nor does this, they still get multiplied by D, our LCD. So this gets multiplied by D. This gets multiplied by D. This gets multiplied by D. All of these terms get multiplied by D. I understand that there's no denominator to cancel. That's okay. If it helps, write this as something over 1 so that you do the cancellation. I don't want you to write 21D over D. The idea is to do the cancellation here. Liam, what equation do I come up with then? Madison C? D squared. Excellent. D squared equals 4D plus 21. That's a lot nicer. We don't have any fractions to deal with. This is a quadratic equation. What do you have to do to solve your quadratic equations? Perfect. You want to get 0 on one side. So I'll subtract 4D and I'll subtract 21. That gives me D squared minus 4D minus 21 equals 0. How do I solve it from here? Factor. All right, good. Do you want to factor it? Yeah, it's a 21. D and D, well, one of these has to be positive, one of them has to be negative. Because you have a positive times a negative will give you a negative. They can't both have the same signs, you get a negative. Good, 7 and 3. Which one, all right, so we got 7 and 3. Which one's positive, which one's negative? Good. The larger one has to have this sign. So there'd be a 7 here and a 3 there. Thank you. Rochelle, what are the answers I get for D? Good. D equals -3 and D equals 7. That's true because I have this times this equals 0. One of these things has to be 0. Typically, you don't have to write that step. You can just switch the signs and you're good. So these are the two solutions to my quadratic equation. Are they going to create any problems with the original equation? If I plug in a -3 or a 7, does that mean I'm dividing by 0 here? No. The only time that would happen is if I got D equals 0 as a solution. So these should actually work as solutions. Yes? Okay. Good on that one? Are we good on this one? You have to check these to the extent that you want to make sure that These don't put a 0 in any of the denominators. They don't, so we're okay there. You can check them on a graphing calculator. I'm not going to show all the details here, but just know that it's possible. If you take your solution and store it, as x, then basically what you're going to do is you're going to type the previous equation in. I typed it in with x's, not d's. But if I get it right, when I press enter, I should get a 1, like 100%. Yay, so I got it right. If I had the wrong number for x, suppose I said 5 was the value for x. If I try it again, this should tell me that I got it wrong, that I got 0 right. So I got it wrong. So it can't actually solve it for you, but it can check it. So just know that. If you want to learn more about it, please see me in my office. Let's try problem number 42. And I think it's about time that you tried working on one. I'll get you a little bit of a start. Z squared over z plus 1 plus 2 equals 1 over z plus 1. Okay, so let's think here. What's the denominator of my 2? 1. So, just keep that in mind. But it really doesn't affect the LCD. What's the lowest common denominator for this problem? Z plus 1. Good. So z plus 1. Everything has to get multiplied by z plus 1, including the 2. So let's rewrite things and multiply everything through by z plus 1. Z squared over z plus 1 plus 2, 1 over z plus 1. Everything gets multiplied by z plus 1. Z plus 1. Z plus 1. Nice. So work on it from here. Okay, so let's pick it up again. We get some nice cancellation here. The z plus 1 disappears. We get some nice cancellation here. Z plus 1 disappears. Where we don't get any cancellation is the middle term. What's left here? Z squared plus 2 times z plus 1. And a lot of you ran into problems right here that you just canceled somehow and you're just left with a 2z. But that 2 has to distribute itself to both terms. So z squared plus 2z plus 2 equals 1. If I subtract 1 from both sides, I'll get z squared plus 2z plus 1 equals 0. Now why am I doing that? Well, I need to get 0 on one side so that I can factor and solve. So z plus something, z plus something. This is the nice case of factorization. There's not too many things that multiply together to give you 1, right? At least integers. 1 and 1. So z equals -1 or z equals -1, right? Now, I have problems with the overhead projector. I don't have the good quality sound that booms out like I want. Something changed in my settings. But in my morning class, I played the think music from Jeopardy. You know that do, waiting for somebody to have like an epiphany looking at this and tell me what's wrong with z equals -1. What's wrong with z equals -1? If you take a look at this and try and put it back into the original problem, -1 plus 1 is 0. You can't divide by 0. My calculator tells me I can't, right? So let's see that. If I did 8 divided by 0, doesn't like it. Does not like it. And our calculator doesn't lie, right? So we'll trust my calculator. In any case, this is an extraneous solution. On the test, it's just enough to cross it out like that, letting me know that you've kind of done a mental check of this and found that it's extraneous. So you have to throw that one out. There's actually no solution to this particular problem. At the beginning of this section, I said you have to check your answers on all the problems. And that's because you're looking for stuff like this. You don't know where it's going to happen or if it's going to happen. You just have to check. There's several different possibilities. You get 2 solutions, both will work. Sometimes you get 2 solutions and 1 will work. Sometimes you get 2 solutions and none of them will work. You just can't tell looking at the problem. So you have to check all of them. Any other questions or thoughts on 42? Let's keep going then. Problem number 46. So 4x over x squared plus 2x minus 3 plus 3 over x plus 3 equals 1. Talk me through this. What should we be doing as a first step? Factor the denominator. We need to determine what the LCD is. So to do that, we're going to have to factor this. 4x something times something. 3 over x plus 3 equals 1. Judy, how does this factor? This denominator? All right, a plus and a minus. They have to have opposite signs, so we get a negative here. 3 and 1, right? So 3 and 1. Now the larger of these has to have this sign. So it'll be plus 3 minus 1. Cool. Thank you so much. What's that make our LCD then? Yeah, x plus 3 times x minus 1. Basically, it's a product of those two things here. That's our LCD. LCD is x plus 3 times x minus 1. everything gets multiplied by that LCD. So let me squeeze that in here. X plus 3 times x minus 1, x plus 3 times x minus 1, and x plus 3 times x minus 1. You're going to get some cancellation. Robert, what cancels on the left-hand side here? What can I do? The x plus 3 cancels. Good. Anything else? X minus 1 cancels, so we're just left with 4x from this first term plus 3 times what? Times x minus 1. Good, thank you. 3 times x minus 1 equals, now over here, is there any cancellation on the right-hand side? Shane, does anything cancel there? No. So on the right-hand side, I just got to FOIL this out. It's going to be x squared minus x plus 3x minus 3. We can clean that up a little bit. There's like terms here. It's x squared plus 2x minus 3. On the left-hand side, let's distribute the 3. Getting closer. Austin, any suggestions from here? Even before that, something simple we can do? Sure. 7x minus 3, bless you. 7x minus 3 equals x squared plus 2x minus 3. Good. What for here? James? Suggestions? Add 3? Good. I would actually get 0 on the left-hand side because you got the x squared term over here. So, yeah, we'll subtract 7x and add 3. That gives me 0 equals x squared minus 5x. Is that prime? Or can I actually factor that? Preston? All right, yeah, we can factor it. Good. How? Is there maybe a GCF? And what would that be? Hey, there you go. Cool, thank you. X times x minus 5 equals 0. So we got the product of two things. This times this equals 0. One of these had to be 0. So what are my choices for x? What values of x work here? Yeah, perfect. X equals 0 and x equals 5. Are both of these kind of safe to use? Can I put both of these in my original equation? Let's take a look here. If I put in a 0, 0 here, 0 here, does that make the whole denominator 0? No. Same thing here. So 0 is okay. So we're okay on that one. How about if I put in a 5? In fact, it's easier to see down here. If I put in a 5, 5 plus 3, that's not 0. 5 minus 1, that's not 0. So 5's okay there and here. Both of these work, unlike our last problem, where we had an extraneous solution. Here, we don't get one. In fact, we get two that work. Any thoughts on problem 46 before we do problem 66? Maybe I should say you do problem 66. Let me get that one up on the board for you. We'll get a little bit of a head start together, and then we'll walk around. 3 over x minus 1 minus 1 over x plus 9 equals 18 over x squared plus 8x minus 9. Like the last one, we're going to start by factoring the denominator. There's kind of a hint that I probably shouldn't give you, but I'll throw it out there anyways. A lot of times, one or more of the factors of these quadratics are going to appear in other factors or other terms in your denominators. So if you look at that, you start thinking, well, probably need an x plus 9 and an x minus 1, you'd be spot on. That's exactly how this one factors. There's actually a little bit of a bonus here. X plus 9, x minus 1 is your LCD. So everything has to get multiplied by that LCD, and that's where I'm going to let you pick things up. X plus 9, x minus 1, x plus 9 times x minus 1, and x plus 9 times x minus 1. So simplify everything from here, and I'll walk around and try and help out. Careful in that second term on the left-hand side that you distribute the negative 1 to both terms. The nice thing about this is that we get rid of the fractions right away. X minus 1 cancels. We're left with 3 times x plus 9 minus 1 times x minus 1 equals 18. 3x plus 27. If you distribute this to both of these, you should get a minus x and a plus 1. Combine like terms on the left-hand side. 2x plus 28 equals 18. There's a couple ways that people solve this. Personally, for myself, I'd subtract 28 from both sides and get 2x equals negative 10. Dividing by 2 on both sides gives me x is negative 5. The other thing I saw people do up here is take 2x plus 28 and subtract 18 from both sides, so they got 2x minus 10 equals 0, and that's okay. They then factored out the the 2, which is going to leave behind 2 times x minus 5. You know what? That should be a plus, shouldn't it? Yeah, there we go. And this is the interesting thing. I had like several people all in a cluster do the exact same thing. You've got something times something equals 0. You can read off the solution here, right? What is it? X equals negative 5. That comes because x plus 5 could equal 0. But a lot of the people say that x equals 2 is a solution. That's not true. 2 can't equal 0. So this doesn't play a part in the solution at all. There's only one solution, that it's x equals negative 5, and that's it. Does this create a extraneous solution? If I put it in the denominators here, am I going to have an issue with any of these? No. So x equals negative 5 works as a solution. There's nothing wrong with it. But please check for those extraneous solutions. Sometimes you're going to find them. In fact, I would pretty much expect one. Hint, hint. Problem number 84. (2w over w squared minus 9 equals 1 over w plus 3 minus 4 over w minus 3. W squared. W squared, thank you. Just like problem 66 and all the other ones we've done on this topic, you need to start by figuring out what the lowest common denominator would be. So 2w, w squared minus 9 is going to factor. How's that going to factor, though? Any ideas? Thank you. W minus 3 and w plus 3. And conveniently enough, a couple of these terms over here also have those denominators, so that our LCD is really just right here. LCD is w minus 3 times w plus 3. So once again, here's where we're going to leave it off. I'm going to walk around and try and help you guys out. Multiply both sides by the LCD. Help each other out, though. I can't always get to all of you, so it would help me out if you lean to your neighbors, say, how's this one working, compare answers, etc. W minus 3 times w plus 3. So lots of nice cancellation on this one, just like the previous ones. W minus 3, W minus 3, W plus 3, W plus 3. So that leaves me with 2W on the left-hand side. On the right-hand side, the W plus 3 cancels, so I'm left with W minus 3 minus 4 times what? W plus 3. That negative 4 is going to distribute itself, so 2W equals W minus 3 minus 4W minus 12. If you were alone, or don't feel alone in struggling with this, a lot of people gave that W minus 4W as 5 or other things. 1 minus 4 is minus 3. So it's minus 3W minus 15 when you combine the like terms on the right-hand side. So negative 3 and negative 12 combine here. For my money, 2 is bigger than negative 3. So I'm going to move the 3W to the left-hand side. That gives me 5W. 5W equals negative 15. If you divide both sides by 5, what's that mean W equals? Good. So the solution to this linear equation is W equals negative 3. Ah, a couple of people, nice job. That doesn't work. W equals negative 3 is going to create problems for us if you try to put it in here or here. Actually, both. So this one's that extraneous solution again. Please look for those things. Extraneous solution. For homework, I don't know, do you want one more? Yeah? Okay, let's do one more then. Let's see, that was 84. Let's try problem number 88. Seven over x minus 5 is equal to 40 over x squared minus 25 plus 3 over x plus 5. All right, want to try this one on your little lonesome? I won't even get you started. Okay. Okay, our LCD is going to be x minus 5 times x plus 5. So all of our terms here have to get multiplied by that LCD. X minus 5 times x plus 5. X minus 5 times x plus 5. X minus 5 times x plus 5. As usual, lots of cancellation. X minus 5 cancels. X minus 5 and x plus 5 cancels. And finally, x plus 5 cancels, so what's left? What's left is 7 times x and 7 times 5. So 7x plus 35 equals 40 plus 3 times x minus 5, so it's 3x minus 15. I kind of squished in a couple steps there. I hope that's okay. On the right-hand side, there's like terms that I can combine, so this is going to be 3x plus 25, 7x plus 35. Since 7 is the bigger of these two, I'll move the 3x to the left-hand side, and I'll move the 35 to the right-hand side. So 4x, those cancel, gives me negative 10. Negative 10 divided by 4 deserves to be simplified down to negative 5 halves. When I subtracted 25 minus 35, I got a negative 10. Does this one work? Is this one okay as a solution? What numbers would be extraneous solutions for this problem? Yeah, 5 and negative 5 would create problems in these denominators. So those would be extraneous solutions. We didn't end up with anything close to that, so we're okay. Those are your solutions. Actually, I prefer to see negative 5 halves. If you want to write negative 2.5 or negative 2 1/2, those are fine. There's just different versions of the same number. For homework, section 7.6, let's see. Try 15 through 45, 63 through 71, 81 and 83. Those will just be the odds.